We're trying to develop offshore renewable energy power plants with co-located data centers, tackling two major demands of our time, which is energy scarcity and data scarcity.
Break down what those things are.
Yeah, what does that mean? So OceanBit is trying to build an offshore power plant using ocean thermal energy conversion as the energy generation technology. So we're drawing deep cold water up to the surface. We're using that to condense a working fluid. We then evaporate that working fluid through surface water temperature, which is warmer. And that process of turning into a gas and generating pressure, we can push that through a turbine and extract energy. Then what we hold is some IP that links data center operation to that power generation process, so that we can utilize all of the electricity that we generate, as well as have an incredibly high efficiency. We also utilize all of the wastewater from that power generation as our excess cooling for the data center. So we're able to compete with regional on-land data center costs, and in some cases, or a lot of cases, beat the cost of hosting ashore.
Wow. And Sam, so tell me, so where, like, the ocean thermal technology is not a new one necessarily, but what's cool about this idea is putting together technologies that couldn't previously be combined. So how long's ocean thermal been around as a concept, and is it a very popular form of energy production?
So it's a two-part on that one. So ocean thermal energy conversion in theory has been around for a really long time. Like, early 1900s, they had an example scientific proof of the theory, but it was the manufacturing support behind. So the production of the large pumps, the heat exchangers, and even the housing that didn't really exist at the time, that kind of restricted that being an opportune or a desired use of energy generation. Leapfrog to 2025, and we've got the oil and gas industry that have spent a significant amount of effort, time, smarts, money in developing systems to pump and move fluids and convert energy in the most efficient way, because their whole business is getting hydrocarbons ashore as cheap as possible. But that technology development is directly transferable to ocean thermal. Then the next hurdle was that computers, mainstream computers and general use data was not a thing 100 years ago, and really not a thing until really the AI boom just created this incredible demand for data center. I've lost the word completely. Thank you. The AI boom has created this incredible demand. Thank you. Yeah, data center infrastructure, and so that's this combination of the fact that we've got the equipment, materials, and theory have all been done before, but no one's built them together like we're trying to do it.
And so when you talk about like deep water versus surface level water, like how far down do you have to go to pull up the correct temperature water, and what parts of the world is this type of technology best used?
So the cold water portion, so we're targeting about 4.5 degrees Celsius. So generally speaking, that's between 900 and 1,000 meters. But there are some locations around the world that you can find that water around about the 750 meter depth. And what we need is it's actually the combination of that cold, deep water and the surface temperature. So the surface temperature needs to be warm. So you start at the equator, and we generally look in the area between 21 degrees north and 21 degrees south. So looking at the Pacific Islands, Southeast Asia, that's definitely where we're trying to kind of keep our attention to deploy first. But across the entire globe on the equator.